Good day everyone. This is our thesis entitled Techno Economic Analysis of the Adaptability of Solar Powered Rice Thresher in Barangay San Jose, Mabini, Bohol. Background of the study. The threshing machine was a machine first invented by Scottish mechanical engineer Andrew Mickle for use in agriculture. The statement of the problem. One of the main problems faced by the farmers of Barangay San Jose, Mabini, Bohol is the nearest gasoline station is 14 kilometers away from their livestand. They cannot buy easily diesel for their diesel engine, and especially in the pro-harvest time, is the difficulty to carry the rice thresher to the harvest sites. Objective of the study: 1. To present an analysis and estimation of a grid-connected photovoltaic power system. 2. To determine the energy production of the solar panels. 3. To provide techno-economic analysis using the gathered data for rice threshing. This will be conducted in Barangay San Jose, Mabini, Bohol. Scope and limitation. The researcher will require quotation from at least 2 providers. The data will be collected focuses only from the San Jose, Mabini, Bohol rice lands. Chapter 2. This is our review of related literatures. The threshing methods, traditional manual threshing, pedal thresher, engine powered threshing, conductors for general wiring, storage batteries, National Electrical Manufacturers Association NEMA, power required for threshing, optimal tilt of solar panels in the Philippines, with the sufficient information collected in these different related studies, the researchers are ready to tackle the methods of this study in the next chapter. Chapter 3. Methodology of the study. This is the process flow with the researchers, procedure, data gathered and actual site visitation, require quotation from providers, planning and estimation of solar panel installation, techno-economic analysis and estimation, computation of data. Under of this is costing calculations, execute and final computation of the gathered, summary, conclusion, implementation, and recommendation. Procedure: data gathered and actual site visitation, required quotation from providers, planning, computation, estimation of solar panel installation. This is the schematic diagram. Solar panel, battery, inverter, the motor, thresher, and the threshing mechanism. The gathered data in Barangay San Jose, Mabini. The engine is Kubota RK70S, which has a maximum output of 7 HP and a continuous rated output of 6 HP. This is the picture, figure 5. Computation and analysis using specifications of 6 HP diesel engine. Solar panel sizing. Diesel engine is using the specification of diesel engine, which is 6 HP for 76 watts. The total load in 8 hours will be 35,808 watt-hour. Power needed from the panel is total load times the 1.3, which is the energy loss in the system. Power needed from panel is 46,550.4 watt-hour. For the size of the panel, power generated from the panel divide power generation factor, which is the size of the panel equals 13,571.55 watts. Selection of the motor, It's based on a diesel engine. A 6 HP single phase motor will be used to drive the rice threshing machine. Based on the specification of diesel engine used in Barangay San Jose, inverter sizing. To calculate the inverter, it must have the nominal voltage as your battery. Size of the inverter. This is the 4476 watts times 20 to 30% bigger than the total watts of the equipment, which is size of the inverter will be 5 kilowatts. Battery sizing equals total watt hours times days of autonomy times the battery loss and depth of discharge and normal voltage of the battery. Battery capacity is 12 kiloampere hour. Presentation, analysis, and interpretation of data. Preparation and the technical plan. The study is intended to determine the feasibility of solar panel installation for the source of power for diesel engine registration in the Barangay San Jose, Mabini, Bohol, whether it's beneficial or not to the farmers. The researcher tabulated the data gathered in the barangay and the quotation from the providers. Datability data of rice threshing in Barangay San Jose. Items under rice threshing. 8 hours per day. The labor cost is 400. It's depend if the owner will get a labor for rice threshing. The fuel cost is 1 liter equals 38 pesos and 1 liter equals to 1 hour of rice threshing. So for 8 hours it costs 304 pesos. Rent of the machine is 300 in 8 hours. Rice grains production, 1 hour equals 10 sacks, 8 hours equals 80 sacks. The price of the Kubota RK 70S diesel engine is 30,000. It is used for trading and rice threshing in the barangay. Costing calculation and techno-economic analysis of the gathered data in Barangay San Jose. The number of days in rice threshing in 16 hectares land is 32 days. The total cost fuel for threshing number of days times the cost of fuel times the number of threshing per year. Cost 32 times 304 pesos times 2. Total cost of fuel for threshing is 19,456 pesos. For maintenance of diesel engine, the inflation rate 2% to 4%, expected inflation 2.4%. Price, the first cost, it's the price of the engine, 30,000 pesos. Lifespan 15 years. Depreciation calculation costs 2,000 pesos. For the calculation for the present, we're using the present worth cost method. First cost plus depreciated price equals the present cost after 20 years is 113,307.14. For the rent of the machine, which is 300 per day, the total rice threshing per year is 60 per days. So the total rent of the machine is 19,000. The total cost of the fuel per year plus the total rent of the thresher per year is 38,656, and the total cost after 20 years is 773,120 pesos. Cost of the total cost after 20 years is the maintenance cost of the engine plus the total cost after 20 years, which is 2,713,600 pesos. Planning and estimation of solar panel installation, the technical aspect of the materials, with the two providers, the Bohol Solar and SolarWorks. These are the specifications of the solar module and the inverter, which is Solis 5 kilowatts hybrid, and the battery is NPP lead acid with a battery capacity 400 ampere hour. Data of the solar panel 19 kilogram, and the area is 1.627 square meter. Calculation of the total number of inverter and batteries to be used. These are the specifications and estimation. In the inverter there are two strings, so 305 volts per string, and it will be multiplied to the demand factor with a total of 385.25 volts, the maximum capacity of each string in the inverter. In the Bohol Solar 335 watt solar panel, open circuit voltage was 40.2 volts. Assume that there are 14 solar panels for the inverter, so there are 7 panels in each string, and equals to 281.4 volts, which is safe because it's not exceed to the maximum capacity of each string, which is the 381.25 volts. So there are 42 solar panels and 14 panels each inverter with a 5 kilowatts type inverter. So 42 panels divided 14 equals 3 hybrid inverters. Specification of the battery 400 hours, and the total capacity battery is 12 kilo ampere hour. So the number of batteries will be 30 batteries. The PV watts calculator software. Researcher used the software for the estimation of the energy production of the proposed solar photovoltaic system for Barangay San Jose, Mapini, Bohol, with the area of the installation site of the solar panels will be 94 square meter, and the system capacity is 14 kilowatts DC. The researcher used Google Map in the PV box in targeting the specific location solar panel installation. So for the system information, this is the system information. For the system information, the researcher input default settings from the result and set the project as a residential rate of 9.91 pesos or 0.2 per kilowatt hour, which is the energy rated of the Buheco. For the results, simulation results, these are the results. There were results from simulation. Simulation of the software estimated the average annual solar radiation was equal to 4.28 kilowatt hour meter per day. Total annual equals AC energy equals to 16,799 kilowatt hour, and the total annual cost is equal to 161,280 pesos. Costing calculation of techno analysis. The project of the solar power installation with a span of 20 years. The project cost of maintenance of the Bohol Solar. Project cost 1,069,020. The outputs of the panels is 14 kilowatt. The total energy hour per day is 43.789 kilowatt hour. Number of batteries is 30,000. For maintenance inverter, the first cost is 34,000, and there are 3 pieces inverter, and For the depreciation calculation, 102,000 divided 15 years of the lifespan. The inverter is 6,800 pesos. For the present worth cost equals cost after 15 years equals 180,878.31 for the inverter. Battery, which is the first cost 16,480. So for the total cost of the battery is 494,400 pesos. The depreciation calculation equals 49,440. And for the present worth cost equals cost after 10 years equals 1,948,496.6. Cost after between 11 to 20 years. Cost after 20 years will be 7,679,347.9. Total maintenance cost for ball solar is 180,800 will be plus 1,048,496.59 plus 7,679,34.9 it will be 9,828,722.8 for the solar works. The same methods for but different solar panel wattage and the rate of installation. This is the project cost. The total output of the panels will be 13.65 kilowatts. Energy production will be 42.48 kilowatts. For the maintenance, first cost of the inverter will 34, and the lifespan will be 15 years. The cost after 15 years of the inverter will be 180,878.31. Battery, first cost and 16,480. For cost of 13 years is 1,948,496.59. So cost after 20 year equals 7,679,347.89. Total maintenance cost will be 9,828,779. Costing calculation between solar panel installation and rice threshing in Barangay San Jose. For the rice threshing in Barangay San Jose, it will be the total cost of 20 years is 2,713,600, while from the true providers is project cost plus maintenance cost will be 10,898,042 and 11,002,622.79. For the summary findings and conclusion, summary: the researcher conducted study on hybrid tide connected solar system storage with alternative source for the rice threshing in Barangay San Jose. The researcher made a thorough study to come up the best result if the proposed solar installation will be beneficial or not. Findings: after the data gathered, tabulated, analyzed, and interpreted. 1. The adaptability of using solar energy for rice threshing is not beneficial economical in the barangay. 2. The competition in the lifespan of 20 years for usual rice threshing is much lesser cost than using the solar power installation, because after the 20 years, the span of 20 years, the cost of is 2.7 million only, while the competition using solar is higher than 10 million pesos. Conclusion: based on the gathered data, there is therefore concluded that the solar power rice thresher is not adaptable for use in Barangay San Jose. It's better to use diesel engine for rice threshing because the total number of rice threshing in a year is only 50 to 16 days for 16 rice lands. Unlike using solar panels, the installation the cost of the project can't return its investment. Recommendation: if you're planning a project using solar panel, it's better to utilize the days and in order to have the return of investments. That's all, and thank you.